Alright, hey guys, this is the second half of the review, test D. Now, obviously put your pencils down. I shouldn't even have to say that at this point. I'm going to be doing this as quickly as I can. I apologize if I go too fast. I hope I don't make too many mistakes like I did yesterday. But it is 11:15. I just finished the classwork video. You know, I still have to do my another lesson plan after this, and I get up at 5. So do the math. I'm not getting a lot of sleep tonight. So I'm going to be rushing, but you can always pause and rewind and stuff. See how this is test D? I did test C a lot more slowly. So if you're having trouble understanding because I'm going too fast, go back and watch test C part 1 and 2. Okay, anyway, on problem number 1, you see this greater than, you're thinking above. This is the above part of the graph, above 4. You make your number line. The critical value is right here. It's the x value. It is -1. This yellow that we just highlighted is leaning to the left, alright, to the left of -1. I'm going to make an open circle because it's not equal to, and like I said, I am going to go to the left. The interval notation for this would be -infinity to -1. Alright, both rounded parentheses. Open circle is always rounded. So that's number 1. Okay, looking at number 2. Alright, we've got a critical value right here. Less than or equal to. Well, this is below. So I'm looking at this part of the graph that is below. I make my number line. Alright, my critical value is the x value. It's 125. It's going to be a closed circle because of the or equal to aspect of it. And clearly this is to the left of the critical value, so I will go to the left. But asymptote alert, okay? Please remember that logarithms have an asymptote on the y-axis, the parent function like this does. So it's not going past here. So I'm not going to go to -infinity. Instead, let's throw a 0 in here and stop the graph at 0. So that's what your graph would look like, and the interval notation would then be 0 to 125. Alright, square bracket on the 125 because it's included, equal to. The 0 is not included, it's the asymptote. So there's number 2. Alright, number 3. You deposit $1,600 into an account that is compounded continuously. Alright, continuously, that tells us we're going to be doing the PERT formula. Okay, for 17 years. They don't give us the interest rate. So, our model will be y equals 1,600. Wait, so we're doing the PERT. So that was the P of PERT. And then we need e to the RT power. Now we don't know r. We know that t is 17, so I'll stick that 17 up there, and so it'll be 17r. That's the model. Include the y. So a lot of you guys are just leaving the y off. Don't do that. The y is part of the model. Okay, now you want to have $18,000 in 17 years. Now this 18,000, that's the y value. This is the amount that we'll have years later. So we're going to have 18,000, okay, eventually. So I'm putting that into the formula. So I've got 1,600 e to the 17r power. I need to solve this for r. First step, divide by 1,600. Okay, notice to make my life easier, I can just cancel out these zeros. Okay, So that leaves 180 divided by 16. Alright, 180 divided by 16. Alright, that is 45 over 4. Okay, the decimal is 11.25. So feel free to use the 11.25, but just make sure you don't round. Like if this had been 45 divided by 3, for example. Okay, bad example. If this had been 44 divided by 3, for example, you couldn't just go, alright, let's do 14.67. Alright, you can't round in the middle of a problem. It throws your answer way off. So if that was the case, you would have to stick with the fraction 44 over 3 instead of a decimal. In fact, just to make a point, I'm going to stick with the fraction. I'm going to stick with 45 over 4. But in this case, if you want to use 11.25, that's fine because it's an exact decimal that's not rounded. Anyway, what did I say? 45 over 4. So this is 45 over 4 is equal to, these are gone, is equal to e to the 17r power. It's time to write this in log form, okay? Start with the log. Start with the base, I mean. So base e, so that means log base e. These two things change sides. So my 17r will come over here, and my 45 over 4 will come over here. Now we don't really do log base e. Log base e is a special case. It is natural log. So we do natural log of 45 over 4. Okay, and then we divide by 17 on both sides. Alright, so that's going to give me r equals. So I'm just going to put this in my calculator. Okay, so clear, I say. Alright, so natural log 45 over 4 over 17. Okay, so that is 0.142 4. Alright, notice how I'm using 4 decimal places. That's because when you give me a rate back, I need it to be a percent, and so I'm going to need extra decimal places, because when I move this decimal, I'm going to get 14.24%. Alright, if you just give me 14, I'm going to mark it wrong. Okay, I need the extra decimals. I need the nearest hundredth. So 14.24%. Oh, and you can't just leave it like this either. You have to give me the percent when you're finding a rate. Mandatory. Mandatory. Okay. So that was it for that one. Number 4. You buy a new car for $28,000. The value decreases by 14.5% each year. Write a model. So this is just simple depreciation. So y equals, so it's going to be 28,000, and then we're doing 1 minus the rate. Alright, and this is moving the decimal point twice. That's 0.145. So that's 1 minus 0.145 to the t power. So boom, there's your model. Now, if you put this in your calculator, you get 0.855. Now, because that's a nice short decimal, it doesn't go on forever, we don't have to round it. It's okay to use this decimal. So that will be more convenient. So that's what I'm going to do. So as I finish the problem, when will the car be worth 1/2 its original price? Well, if it's worth $28,000 right now, half of that is $14,000. So I have $14,000 is equal to $28,000 times 0.855 to the t power. Of course, we will divide by that 28,000. Okay, and I can shorten this up by doing this. All right, 14 over 28, so that'll be 7. It'll be 1/2. Yeah, silly Burton, thinking about it. Yeah, we knew it was going to be 1/2 because it has to be 1/2 of its original price. So 1/2 is equal to 0.855 to the t power. A mistake I've started seeing, some kids try to divide this base away. You can't divide a base out of the this side of the equation. You have to rewrite it in log form. So starting with the base over here, what we have is log base decimal. Okay, and the 1/2 and the t, those are going to change sides. Okay, so I'm going to have t over here. I'm going to have the 1/2 over here. Alright, so this is going to give me the answer. Of course, I need to do change of base. So I have to do log 1/2 over log 0.855. Alright, so just put that in your calculator. Log 1/2 over log 0.855. So you get 4.42. Alright, so that's 4.42 years. Please understand that you cannot simply use the table feature on your calculator and come up with 4 years and think that's close enough. No. Do not use the table feature. You have to show your work, do all these calculations, do the log, change of base, all of this. If you don't, you will get no credit at all. Just don't do it. Number 5, Ooga Booja. The population was 2,500,000 people in 1990. Since then, the population has increased at a rate of 3.4% each year. Write a model. Okay, this is simple growth. All right, it's not compound interest or anything. So we will write y equals 2,500,000. All right, times 1 plus the rate. Now that rate is 3.4%. So that's if you move the decimal point twice, that is 0.034. So it's 1 plus 0.034. Okay, to the power of time. So this is the model. Okay. Please understand that if I add these, 1 plus 0.034 is just 1.034. So I'm going to definitely do that. So 1.034 is cleaner. If you left it as addition, that's fine. Alright, but this is more convenient. So let's find the current population in 2014 of Ooga Booja. So I just need to put something in for time, but I need to pay attention of when my starting year was. So the starting year was 1990. I'm going from 1990 to 2014. So that is 24 years. Right? Yeah, it's 24 years. So that's why, alright, So t is equal to 24. That's what's happening. So I'm just going to put this in my calculator, but I'm going to let t be 24. Yeah, that's great. Can I move this off to the side sufficiently? Okay, that'll work. So here I go. I've got 2,500,000 times 1.034 to the 24th power. Okay, so this will be my population. I'm going to round to the nearest whole person, so I'm going to round this up to a 5. So let's see, 5,577,000 Alright, 415 people. Okay, that's the population today. Okay, when will the population reach 3,000? I mean, sorry, 3 million. Well, it says when will it, but we should say when did it, because it's already 5 million. Remember, you may not use the table function of your calculator. I need to see your work, and I want decimals. So, the 3 million, that's the eventual population. That's the y value. So we're going to plug that in. Let me leave myself as much space as I can. So I've got 3 mil equals, all right, 2,500,000 times 1.034 to the t power. I'm trying to find t. I must divide. All right, divide by 2,500,000. All right, just so I don't have to type as many zeros. Please understand I can cancel out equal zeros, okay? So I've got 1, 2, 3, 4, 5 zeros here, 1, 2, 3, 4, 5 zeros here. So I can cancel out these zeros. So I've got 30 over 25 that I'm dealing with. It's a lot less typing. So 30 over 25. Okay, so that's 6/5. As a decimal, that would have been 1.2. So you're welcome to use 1.2, but again, if this had been some decimal that went on, you couldn't use it. So you'd have to use a fraction. I'm going to use the fraction just to show how show how the pros do it. So 6/5. So I've got 6/5 is equal to 1.034 to the t power. Now it's time to put this in log form, starting with the base. Okay, so this will be log base decimal, 1.034. Now the t and the 6/5 are going to trade sides. So the t is over here, and the 6/5 is here. Alright, look familiar? Right, this is just how we did the previous problem. Okay, but to put this in our calculator, we need the change of base. So we need to be able to do log of 6/5 over the log of this decimal. And so that's what we'll do. Okay, so log 6/5 over log 1.034. Okay, so that is 5.45 years. $5.45 years. I must have this decimal to the decimal. Okay, don't just say 5, don't just say 6. 5.45. Now we also need the year, though. I mean, they gave us the original year was what, 1990. Okay, so if I do 1990, and this is 5 years later and some change, so let's just say 5 years later. This will happen sometime during the year 1995. Okay, you know, it's 1995, and like 6 months is still 1995. So 1995. Okay, but the decimal, that's the key. That's the main thing I'm going to judge you by. Alright, if you just put 5, you get no points. If you didn't show all this good work, you get nothing. Alright, number 6. Did that sound mean? I didn't mean to sound mean, guys. I still love you guys. Okay, just got to show your work, okay? Alright. Now, you deposit $8,000 into an account that earns 7.9% annual interest compounded continuously. That's our PERT again. Okay, so that's going to be, so already we have y equals 8,000. Whoops. I said 8,000. So that's the P in PERT. And then E, now the rate, okay, this is 0.079. Alright, got to move the decimal twice. So 0.079. And then T, that's the model. How long will it take for your investment to triple? Well, they gave us an actual number. So it's 8,000 to start with. So if this triples, this 8,000 will become 24,000. All right, that's 8 times 3 is 24. So triple is 24,000. So that will be our y value, because that's the eventual amount that we have later. So that's why we go 24,000. All right, that's triple, is equal to 8,000 e to the 0.079 t power. Of course, we're going to divide both sides by that 8,000, and we will not be surprised what we get. Alright, of course I can take those out. 24 divided by 8 is 3. And yeah, we knew that was going to happen because it tripled. We purposefully made it 3 times bigger. So we have 3 equals e to the 0.079 t power. Time for some log form, you guys. Start with the base. So this would be log base e, and these parts will trade sides. So the decimal is going to come over here. So I'm going to have 0.079 t out here. The 3 is going to come over to the right side like this. Okay. Now we don't do log base e. All right. This is natural log. This is just natural log 3. So we have 0.079 t is equal to natural log 3. If I want to get that time, I will divide by this decimal, 0.079. Okay, so that is going to give me my time, the how long. Okay, I can just put this straight into the calculator. Okay, so that's going to be natural log 3. Didn't close it. Let's try that again. Natural log 3 over 0.079. So that is 13.91 years, round up. Alright, do not use the table function on your calculator. I cannot overemphasize this. Okay, if you look on your calculator and you're estimating, this is pretty close to 14. So you might go, oh yeah, 14. If you just put down 14 years, okay, I can't spell years all of a sudden. If you just put down 14 years, you will not get any credit. Alright, show all this work, give me these good decimals. You know, this is all about logarithms, people, so use them. Alright, let me just erase this, by the way. Okay, so that was number whatever it was. 6. Number 6. Alright, moving on to number 7. You deposit $9,000 into an account that earns 12.5% annual interest compounded monthly. Alright, that means we're going to be using that formula, the one that's like this, like y equals principal times 1 plus the rate over n to the nt power. Okay, this is the formula for when we have compounded semi-annually or quarterly or monthly or daily or weekly. Alright, monthly is an n value of 12, alright, 12 times a year. So, okay, well, I guess I'm going to need more space. So that formula will become, so you deposit $9,000, so that's your initial amount. I will do 1 plus. Now the rate, moving decimal twice, that's 0.125. Okay, over n, alright, it was monthly, so we said that would be 12. And then up here it's nt, so that's 12t. So this is your model. I'm curious if this will come out to be a nice decimal that I can actually use. So I'm going to check it out. Okay, if I do 1 plus 0.125 over 12, let's see what we get. That's a pretty ugly decimal. I think I will find it easier just to stick with it the way it is. I'm not gonna, you can't round it. That's the main thing I need to emphasize to you. Don't go, oh, 1.01. No, don't do that. I have one kid that likes to just use all the decimals. I'll allow that if you want to sit there and use 1.010416667 and carry that through all your calculations. Be my guest. But I'm just going to use it the way it is. Anyway, how long will it take your investment to double? Well, if we started off with 9,000, if it doubles, that will be 18,000. So the equation, so that 18,000 will be the eventual amount y. So we'll have 18,000 is equal to 9,000. Or I'm just writing down the rest of the model here. 1 plus 0.125 over 12 to the 12t power. I need to find 12. Find t, sorry. Okay, clearly I'm going to divide both sides by 9,000. And it is no surprise that we get 2 for the answer from that, because it's doubling, so that should be 2 times as big. So these are gone. So I've got my 1 plus 0.125 over 12 to the 12t power. Okay, so we need to rewrite this in log form to get this t out of there. So in log form, we start with a base. So this is going to be log base ugly thing. So 1 plus 0.125 over 12. That's the base. Now, the 2 and the 12t are going to change sides. Alright, so the 12t is going to come over here, and the 2 is going to come over here. Okay, so the last step, we got to get that t by itself, so I'm going to divide both sides by 12. Like that. Okay, so this is what we're going to try to put in our calculator. Obviously there's no way to directly put log base something of something in the calculator, so you got to do the change of base formula again. Okay, so the t would equal, so change of base, I need to do log of 2 divided by log of this over 12. So I've got log of 2, okay, over log of 1 plus 0.125 over 12. Alright, I've got log this divided by log that. Now remember that this whole thing is being divided by 12. Okay? If you're clever, you can type this entire expression into your calculator all at once, which I think I will do that right now. Notice the 12 is in the denominator, so this is my favorite way to do it. So the 12 is in the denominator all by itself. The numerator in blue here is a fraction, so I can just go to the numerator and make a fraction. So this is where I put my log 2, okay, and my log 1 plus 0.125 over 12. Okay, that is it. This is what is on my screen right here. Kabam! 5.57 years. Okay, that's how long it will take to double. Alright, 5.57 years. Okay, if you're uncomfortable typing in the stacked up fraction, I'm just going to show this one more time. You could do this one part at a time. So I could do log of 2 divided by, I can use the old-fashioned divided by, log 1 plus 0.125 over 12. Okay, so I got this decimal so far. Now I just need to divide by 12. So I don't round, I just go divided by 12. And you get the exact same answer if you do it that way. So whatever you're more comfortable with. Okay, so that was number 7. Let's go on to number 8. Alright, so we need to solve the inequality algebraically and make a graph and interval notation. So what we do is we basically look at the related equation here. So 6 to the x minus 7 equals 1296. This will give us our critical value. Now looking at the chart real quick, okay, this guy, man. Get out of my face. Update. Postpone. Where was I? 1296. So you see the 6 and you see the 1296. That is 6 to the 4th power. So we can do like bases quite easily. So we have 6 to the x minus 7, and then we have 6 to the 4th power. So that means the powers are equal. So x minus 7 must equal 4, and if you add 7 to both sides, that means x equals 11. So that is our critical value. So let's go ahead and draw our number line. Okay, and there's 11. Now, this is going to be an open circle because it's not equal to, so I put an open circle. So I just need to know if my solutions will be to the left or to the right. For that, we'll use a test value. Okay, now I often use 0, but this time I will prefer to use a test value of 7. So I've shown it with 0 many times, so it's time to take you to the next level. I'm going to test x equals 7. Now, why did I pick 7? I really want to have 0. And I can use a little bit of brain power here and understand if x were 7, then I will have 7 minus 7, and that's 0. So yeah, that's genius. You're impressed. So I have 6 to the 7 minus 7 power, and I'm checking to see if that's greater than 1296. Question mark, I don't know, I'm asking. So this would be 6 to the 0 power like I wanted. And is that greater than 1296? I think we see what's about to happen. Anything to the 0 power is 1. Okay, I don't need a calculator or anything. So that's 1. Is that greater than 1296? Of course not. That's a fail. So as far as on your graph here, our test value of 1 would be over here to the left somewhere. So that means this is the no side of the critical value. So that means this is the yes side. Okay, this is the side where all the solutions are. So this is where I will draw my arrow. So bam, there's your graph. Interval notation will be from 11 to infinity. Okay, we will use round parentheses even on the 11 because of the open circle. A rounded parenthesis means the same thing as an open circle. It means not equal to. Don't include the 11 as one of your solutions. So that's it. Okay, number 9. Okay, this is a log function. We've got to be a little more careful. But still, the first step is to find the critical value by looking at the related equation. Now, this doesn't have a base showing, so that means the invisible base here is 10. So I am going to rewrite this in exponent form to help me solve it. So start with your base. These two will change sides. So I'll have 10 squared is equal to 4x. So that is 100 equals 4x. And then I divide by 4. Okay, so that is going to give me 25 is equal to x. That is my critical value. So I'm going to go ahead and graph that. So here's my 25, let's say. This is going to be a closed circle because it's or equal to, so that includes the 25. So it's just a matter of will it be to the left or to the right. We don't have a graph, so we need to use a test value. We can't use 0 because you can't take the log of 0 because that is an asymptote. In fact, at least temporarily, let's include 0 in our picture. So here's 0. In fact, let me just stretch this out. Okay. Remember that log functions have an asymptote at 0. So you can't get to 0 and you can't go past it. So anyway, so I need to pick some other value. I'm going to pick 1. Alright, so test value of 1 would be like right there. So here I go. So I'm going to test an x value of 1. When you test this, you have to plug it back into the original equation. None of this switching to exponent form stuff. You've got to put your 1 or whatever value you're using right there. So you have to go log 4 times 1 is less than or equal to 2 question mark. We are asking. 4 times 1 is just 4, so this is just log of 4. Is it less than or equal to 2? Okay, that's a question mark. Just put this in your calculator. Log 4 to get a decimal. Alright, that is 0.60. Okay, is that less than or equal to 2? Yes, it is. So that means this is the yes side, and this is the no side. This is where all the solutions will be. So my solutions are going to the left, but they do not go to negative infinity. They have to stop at the asymptote, and they don't quite reach it, so I make it an open circle, and they definitely don't go past it. So here's my graph. Okay, you don't really show the asymptote on a number line, so that was just for instructional purposes. Okay, but you will want to show your 0 and your 25 to show that it stops here at 0. And then your interval notation will be from 0 to 25. So you will go 0 to 25 and use a square bracket, closed circle. It's equal to, we include the 25. Okay, so that is it for that. Please understand, when we did the log of 4 and we put that in the calculator, I easily could have given you one that had a base here other than 10. So let's say this had been like log base 3 of 4, and we were checking to see if that worked or not. I guess that's supposed to be a number. We're checking to see if that was less than or equal to 2 maybe. Please understand, you would have to do the change of base then. You would do log of 4 over log of 3, and you'd get your decimal that way. Okay, that was just a quick hypothetical. Alright, so that was number 9. Okay, number 10, solving this stuff. So we need to get the base by itself. So subtract 6 from both sides. So that's going to be e to the 7x plus 8 power is equal to 12. Let's go to log form. Start with the base. In log form, that's log base. These two guys change sides. So I'll have my 12 and then my equals 7x plus 8. Okay, we don't really do log base e, we do natural log. So that's natural log 12 is equal to 7x plus 8. So now we will keep going. Subtract 8 from both sides. Do not do 12 minus 8 and get 4. You can't do that. Just stick the minus 8 on the end. And then we have to divide by 7 on both sides. Okay, so we have that. So this will give us our answer. We will just put this in the calculator. Again, I prefer to just type in the whole thing. It's my style. Okay, so I will do natural log of 12 and then minus 8 and then over 7. I love fraction mode. So your answer should be negative 0.79, round up. Okay, that is your answer. Okay, you're welcome to do this in pieces and go natural log 12, okay, minus 8, and go ahead and hit up the decimal, and then you know that we still need to divide by 7, so you could just go divide it by 7. You'll get the same answer. Okay, number 11. Oh, this is already by itself. We could sit here and do log form again, but I'm noticing the 729. So another way to do it is to use are like bases. 729 is 3 to the 6th power. So the most efficient way to do it, I think, would go, oh, this is 3 to the 6th power. So the exponent should be equal now. So that'll be 5x minus 4 is equal to 6. Add the 4 to both sides. So I've got 5x is equal to 10. Divide by 5. Okay, and I get x equals 2. Oh, look at that. It came out nice and even. It's very odd that it came out so even. Haha, get it? See what I did there? Even odd. Alright, we are on the last problem. And on my clock, it is 12:03 a.m. So just appreciate what I do for you guys. Alright, feel me? Okay, so I see the like bases here. So please understand, when you multiply with like bases, you add the exponents. So this is going to give us 9 to the, alright, 6x plus x, that is 7x. Negative 5 plus 1, that's negative 4. That's going to equal 100. Okay, great. There's no like bases we're going to be able to do here. So let's go ahead and rock the log form. Log form, you start with the base. So this will be log base 9. And these parts will change sides. So it'll be log base 9 of 100 is equal to 7x minus 4. So let us add 4 to both sides next. So that'll be log base 9 of 100 plus 4 is equal to 7x. Alright, then I need to divide by 7 to get that out of there. Okay, so that is going to give me x. Alright, this needs to be put in a calculator. Okay, so I like to just type it in all at once. Oh wait, change of base. Yeah, can't type that in directly. So we're going to need to do log 100 over log 9 to get her done. So we'll have log 100 over log 9. That's this part. Alright, we still have the plus 4. And then all of that is over 7. Okay, so we'll put this now in our calculator. Okay, so here I go. The denominator is 7. I always like to do that first so I don't get confused. The numerator has a fraction in it, so I'm going to put a fraction in the numerator. So that's this. So here comes my log 100, okay, over log 9. Okay, but it's also got this plus 4 up there, so there it is. Okay, so this is 0.87 is the final answer. Okay, 12:06 a.m. We are finally finished with this lesson. I hope this was helpful to you. I will see you on the next video, people. Hope you didn't copy me too much with your pencils. Yeah.